Made it.
All right, good to see that, Charlie. All right, well, good afternoon and good morning to everybody. Thanks for joining us today. My name is Haresh Malkani. I'm the CTO for CESMII, and in today's webinar, we have a fantastic group of people who are going to be joining me for a manufacturers panel, and what you'll hear from them is their perspective on innovation and value that they're seeing from the projects that they're involved in. And this is all, part of our effort at CESMII to bring you a lot of the content that was originally supposed to be part of our annual meeting, which obviously got canceled and postponed. But even having said that, I'm absolutely sure that the panelists that we have today will provide you with a great experience in terms of sharing their perspective and making it meaningful for you, even in this remote manner. In terms of the logistics, we're going to be doing the panel Q&A in a moderated fashion for the first 40 minutes or so. And then we'll open up the lines, well, not the lines, but we'll open up for question and answers from our audiences through the Q&A tab that you should see at the bottom of your screen, your Zoom screen. So as you think of a question during the session, please note it down, and towards the end we'll pick them up and answer as many as we can in the allocated time. The session is being recorded, so we will make that available to you shortly after we are done today. So with that, let's get started with a obligatory statement here, which I'll read. As participants in this meeting, we need to be mindful of the constraints of antitrust laws. There shall be no discussion of agreements or concerted actions that may restrain competition. This prohibition includes the exchange of information concerning individual prices or any other competitive aspect of an individual company's operation. Each participant is obligated to speak up immediately for the purpose of preventing any discussion falling outside these bounds. All right. So I said that you are you have the benefit of listening to four of the panelists who are industry members on our projects, and in addition to that, we also have one representative from the Department of Energy, and I'll make the introductions shortly. But what you'll hear are three themes in the Q&A. One is around innovation, second is around accomplishments, and third is around value. And we'll have a good set of questions that we'll ask the panelists, and we'll touch upon these topics for hopefully each of the projects that they represent. So what we'll do is we'll have each of the panelists introduce themselves, tell us a little bit about themselves, do a elevator pitch on their projects, their respective projects, and then we'll go on to the moderated Q&A, and then for the audience Q&A. Okay. So just to give you a little bit of a background on what these projects are, we have four panelists today, and they represent the four projects that are highlighted in the red boxes on the screen. And what you see here is the first one is around data modeling, essentially for the additive manufacturing processes. And Honeywell is the project lead, and we have representation from that company today. The second one that's highlighted is called inferential modeling for driving out energy waste, and this is focused on the food and beverage industry, and we have General Mills represented today from that project. The third highlighted box is for steel continuous casting, and we have ArcelorMittal with us today. And the fourth one is around chemical processing. The project is led by Texas A&M, and the industrial member is Linde, and we have representation from that company. And what you see on the right-hand side is our articulation of how these projects fit into the larger ecosystem that makes up smart manufacturing in terms of its building blocks and components. So in the conversation today, you will get some flavor of some of these elements on the right-hand side, but more particularly a manufacturer's perspective on how this particular project is bringing that out in terms of innovation, in terms of the value that they're getting out of the project, and the value that they're providing back to CESMII and the US manufacturing industry. So with that, why don't I just quickly name the panelists, and then what I'll ask them to do is tell us a little bit about themselves and the project. So we have Dr. Greg Colvin from Honeywell. We have Chris Damsgard from General Mills. We have Larry Megan from Linde. We have Charlie Romberger from Arcelor. And we have Sudarsan Rachuri from the Department of Energy. So I'll be moderating this. I don't look like that picture anymore, but I apologize for that. And with that, why don't I begin with Honeywell? So Greg, if you can maybe tell us a little bit about yourself first, and then do your elevator speech on the project, maybe a couple of minutes, 2 to 3 minutes.
Sure. Hi, everybody. So my name is Greg Colvin. I'm the Technical Fellow for Advanced Manufacturing for Honeywell. And I cover all things additive, castings, forgings. My background, I spent prior to this tenure for 4 years at Honeywell Aerospace. I was at the Honeywell portion that helps run the nuclear arsenal enterprise for the Department of Energy. So I was there for a dozen years. Before that, I was at Howmet Castings, which was part of Alcoa. And so from this program standpoint, it really is CESMII came along at the right time, in my opinion, to help provide funding in this area, because additive manufacturing really needs good data collection that can help with actionable insights, and to really help these process engineers develop new processes for new parts. And a lot of activity had been funded in this area, but really had not pulled together all those different elements that had been learned, and to try to really make it actionable. At the same time, there was a lot of parts being made over the last 18 months, couple years. So now we know a lot more today than we did, say, 5 years ago about what's required to make a good part for additive. So the timing was great for this program, and the outcome of it is to identify and tap into methods that can analyze data to help people make new builds for additive. And so really is a good program, one we're very excited about. And I'll just give you one example. Layer picture data is available, being sold by equipment builders, but they have no way of telling you which layer pictures may have a particular issue. So you might get a file of 3,000 layer pictures, and then the process engineer has no idea which of those layers might have an issue. So we're developing algorithms, and we'll share that with folks, CESMII and everybody, that might tell people making AM processes, look at layer 1050. You don't have to sort through every layer in order to figure out where you might have part problems. And so that is very valuable. Engineers otherwise tend just not to look at the file at all. So that's an example of data being collected that we really need CESMII to help analyze and help engineers make better decisions. Okay.
Excellent. Thank you, Greg.
Sure.
So General Mills is part of this project that is being led by ThinkIQ. So Chris, if you want to just maybe give us a sense of what your role is and what this project is about.
All right. Well, good afternoon, everyone. Chris Damsgard, work at General Mills in engineering. I'm a principal engineer in our global reliability organization, where our mission is to improve our existing asset base for manufacturing, sustain those improvements so we can extend the life of our equipment. And in this case, I focus heavily on information, driving behaviors, decisions, action through tools and information. In this case, we're going after energy, big opportunity, in a way that's very non-traditional. Traditionally, we would go in, put in meters everywhere, and the meters would tell you each piece of equipment how much energy you're consuming. Electricity is one of the most common types of energy we're going to go after. And that's very expensive. It's very slow. And so could we get further faster, like in an afternoon rather than 6 to 9 months, if we just paid attention to our control system, which already tells us which equipment is on? Can I infer, can I model and calculate an estimate of how much energy I'm using based on what's going on my plant floor? This motor's turning, that dryer's on. I'm running a thicker product today than I was yesterday. Do I know enough about my process that I can tell you how much energy I'm using without putting meters in place? Because at the end of the day, it's having that context wrapped around what's going on your floor that's going to help you drive out any kind of waste or get after improvement opportunities. And so the vision here is connect to that plant floor info, model it, bring context around it, and help that plant engineer get started in an afternoon rather than 6 to 9 months, and with more relevant information to boot.
Very good, thanks, Chris. So the next project, this is being led by Texas A&M, and we have Larry Megan from Linde. Larry, if you can take it away.
Sure, thanks, Haresh. Yeah, hi everybody. Larry Megan. I'm a director in Linde Digital, which is our digital innovation organization. So we're responsible for bringing new innovations across all aspects of the business. Linde is now the world's largest industrial gas company. It was formed out of a merger of Praxair, which is the side I come from in Linde, about a year ago. And so this project is really about what I'll call smarter digital twins. Back in the old days, we used to just call them models, but now digital twin is a popular term. And while there's lots of experience and history around developing digital twins within our industry, in this example, the air separation business, the challenge that we have is more around sustainability. How do you, anybody can, I wouldn't say anybody, but many people can build a model. How do you make sure that it continuously matches the operation? And if you look within an operating facility or the ecosystem, there's different digital twins at different levels of operation. And so how do we manage to keep all of those in sync? And so we still consider that to be a very open question, and are really happy to partner with A&M and multiple folks as part of the CESMII ecosystem to try to solve it. Thanks.
Excellent, thanks, Larry. And the fourth project is for steel production, steel continuous casting, and we have ArcelorMittal as a project lead, as well as the manufacturing member that's representing the project on today's call. So Charlie, if you can take it away.
Okay, thank you, Haresh. And hello, everyone. As Haresh said, my name is Charlie Romberger. I've been involved in steel R&D research for, well, since 1968, starting in the sensors area, and then actually working through sensor applications and quality sensors within mostly our rolling and finishing process area. So the casting area here is a new area for me, at least the focus that we have on this particular project. But I've been actually the member of, or representative, ArcelorMittal's representative to the Smart Manufacturing Leadership Coalition, which was the predecessor, of course, to the CESMII organization. I'm currently the representative, CESMII representative, and actually the administrative lead on this project. As you can see, the overall goal here really is to, it's focused at zero defect slabs in continuous casting, and it's really focuses on energy reduction by improving slab quality to reduce both caster and downstream process losses, and to improve our overall productivity on the caster itself. Over on the right-hand side of the photo, you'll see that the caster is represented there in the center, and it basically receives hot metal from our steelmaking operations. The cast product is a semi-finished product, and basically it typically goes into two production streams. One is are plate processing, and the other is what we term light flat rolled, which typically is hot rolling, cold rolling, and then coated products. So the scope of the work at this point is to basically begin to integrate the use of upstream data and downstream data, as well as the existing caster sensor technology and process technology, and begin to actually apply AI data analytics, and of course, hybrid model implementation to achieve the goals that we have as far as slab quality improvement and productivity improvement on the caster. Thanks.
Thank you, Charlie. So that's just setting the stage for our listeners here in terms of the types of projects that are being represented today. I think we'll begin the Q&A here if the panelists are ready. You know, one of the things that we always need to kind of understand is that, you know, before you take the first step in your journey in smart manufacturing, you know, whatever pieces of the puzzle that you're after and whatever problems that you're trying to identify, I think it's important to do an assessment of the current state of, you know, where you are in terms of the technologies that will help you get there, right? So in your cases, in your respective projects, what was the current state of the technologies, and what is it that you needed to do in terms of innovation in your project to get to that end point? So let me begin with Charlie in the steel production process. Could you maybe give your perspective there?
Sure. ArcelorMittal has been basically implementing and using digital technologies for quite a long time to control our various processes in the manufacturing stream. Sensors, level 1, level 2 modeling, and process control have been developed internally or are being supplied by our steel industry OEM vendors for a long period of time and are commonplace within the manufacturing operations. The one thing, time series data is typically readily available, as is warehouse data on individual processes, but typically that data is not shared amongst the processes, okay? So one of the key issues that we're looking at in terms of innovation is to break those data silos, if you will, and begin sharing information across the entire stream. So from the standpoint of innovation, that of course is one key issue, is begin to actually make data available from steel making down to the finished product, and then basically begin to apply new techniques, if you will, or data analytics and additional hybrid modeling, which will incorporate both physical modeling as well as data modeling to address both the slab quality and the productivity issues.
Great. So how about you, Larry, from a standpoint of a chemical process that is, again, very capital intensive? I can see the background that you have there. So how did you think about what was the technology that you needed, what the current state was, what wasn't available? How do you want to, you know, bridge that gap? Okay.
Sure. So in our industry, which is the industrial gas business, so first, it's really energy intensive. We'll probably spend as a company over $3 billion on energy this year. And so anything we can do to squeeze energy out of the plants is really, really important. And so the challenge that we've had, you know, people, as I mentioned, people have been working on models, and we've been developing models to support our plant operations for many, many years, whether it be at the asset level to understand the reliability and the efficiency of a piece of equipment, at the process level, whether it be to support just the efficiency analysis of that process or the advanced process control system that's tied to it, or at the higher levels, right, at the multi-plant optimization planning levels. And so we have a lot of solutions in that space. The challenge that we have is that, as I say, we have models and solutions to support each layer, but they're all custom for that layer and the specific questions you're trying to answer. And so then the problem is that you end up in a plant, you end up with 4 or 5 different quote unquote digital twins to help you assess the operation or control the operation of that facility. And so then of course the challenge becomes, while each of them bring value, making sure that they're in sync and making sure that they're sustained as things in the process change, whether it be physical changes, instrumentation changes, etc., puts a pretty big burden on our engineering support staff and our operations support staff. And so we just felt that that was an area that was not, had not been touched on too deeply, at least especially when you look across multiple layers in the system. And so we just felt there was an opportunity, like I say, to partner with various folks, the CESMII team here, to see if we can come up with a more sustainable solution. At the end of the day, you know, we're all challenged to do more with fewer people and, you know, and fewer experts available. And so what things can we do to facilitate those kinds of challenges?
Great, great. Chris, I think in your case, the framework around the problem is a little bit different and unique in the sense that, you know, you're trying to do something without sort of investing more money into actual sensors for energy, and the emphasis on, you know, putting that burden on more on the knowledge side, right? Knowledge and software side. So what was missing for you when you looked upon that as a problem? What was missing? And then, you know, you partnered with a technology company, right, to sort of fill that gap. So maybe your perspective on how you went about doing that.
Yeah, so starting with the company that we partnered with, their background is putting together flows of material largely. And in this case, we're just going to treat energy as a material and put that right alongside the actual context of our product that's flowing. And so again, that's what brings the context that I spoke of earlier, so that we know if we're running, you know, product A versus product B, what should happen to the energy, what's actually happening, and to bring that context in. But really the goal and what's missing is the quick and easy. It's got to be fast. It's got to be low cost. I can get started and make improvements immediately if I've got large gaps in terms of what I'm expecting and what actuality is. If I can just simply see them and be able to identify that that context that's wrapped around that data. So what does that mean? That means meet me where I'm at. Again, I've got a control system. It's telling me what's running and not. I've got a plant floor data system that tells me what product I'm running. Can we just put those things together quickly to be able to generate that context right away? You know, I spoke earlier about the cost and the time to put in meters and so on. None of these solutions really, it doesn't matter how inexpensive or speed that comes with them until they have that context. Without the context, it's still just data, and you have to supply that yourself. You have engineers going, well, I know here's kind of what was going on. Well, how do we get past that easily? Because we've got junior folks that are coming in that don't have the same experience that our senior folks did. So when it comes to, you know, just knowledge transfer, you can't do it all through somebody's head. We shouldn't be doing it just through people's heads. We want to, you know, institutionalize the knowledge through our tools as much as we do through experience.
That's great. So Greg, I'm going to switch gears a little bit here. So, you know, we've heard from the other three here, companies that represent, you know, processes that have been around for quite some time. Your project and your company, the way it's involved in this particular effort here, is coming in from a more advanced manufacturing side. So additive manufacturing has not been around for that long. So if you look at that industry and what you're trying to do, what was that one or two big challenges that you were seeing that said, hey, we need to attack this particular problem and we have to attack it in this particular way?
Right. So if you look at the industry, like you say laser powder bed fusion, which is really what the portion of AM that this concentrates on, the challenge is there are no historical parts, right? There are no legacy parts. People are creating new, once you know an alloy is buildable and you think a component is generally, you think you can build it, now you have to develop a process for it. And in developing that process, you really need access to data and access to, you have these equipment that can collect data, but nobody really knows what to do with the data because proper data analytics was really not applied. And yet maybe perhaps even some data was not being collected that should have been. But the challenge in the industry, and I'm not just speaking for Honeywell, I'm just saying for the whole industry, the challenge is for folks to be able to quickly be able to develop new processes for buildable parts and to use that data to improve the decision making. And so that's where this project was particularly valuable for us because we knew our supply chain was going to all at once. If you think about it, in modern history of manufacturing, this is one of the few times that all at once a whole industry is being started up, right? And so what's happened is you have these pockets of people with 3 or 4 machines and 2 engineers trying to develop processes for new parts. They need access to data. They need access to data that can help them make decisions better. And yet, surprisingly, some of this people were paying an extra $100,000 for data collection systems, yet there was nothing that really tied into how does that help you make better decisions. What of that data is goodness in terms of in making better microstructures or making better mechanical property parts? There really isn't that. And so really in the history of at least making mechanical parts, this is really an unusual event where all these startups happen at once. And of course, Haresh, you knew that going through Arconic and folks that really we collectively as a community in AM need to figure out what this data means. This CESMII program is particularly valuable because it really wants to concentrate on data analytics, understanding what the data means. And that's important to Honeywell, but it's important to the supply chain and all these folks who have started up these companies, right? And both in the US and outside, but in the US, of course, is what we're looking at.
Yeah. You touched upon something that brought a thought in my mind, which was, what to do with the data is something that, we've heard many companies say that, we got plenty full of data, but we don't know what to do with it, right? That's the common thing that we hear.
Right.
And one of the things that we've been sort of promoting is that when you're looking at that aspect of your smart manufacturing journey around the volume of data, I think it's important to go back and say, why is it that you need that data? Start with the why first, right? You say, here's the problem I want to solve. And in order for me to solve this problem, I need this data. And then go through that journey rather than saying that I got, cheap sensors, I got cheap data acquisition, I got this, and that, let's just pump everything out, right? And that just
you don't want to shotgun it, I don't think, Haresh. I think you want to start with decision making. What decisions do you have to make? What decisions do you have to make that impact yield, that help reduce the labor content, and see what data do you need to collect to impact those decisions. I'll give you an example. Melt pool monitoring was added to a lot of this equipment. And for research, melt pool monitoring may be fantastic, but I yet have seen any value for melt pool monitoring in terms of production parts or parts you can build. And so therefore, that's an example of you're collecting data, great for research, but not so great for other aspects. Yet melt pool monitoring, people were paying $150,000 extra to add it to their machine. $150,000 is a lot of money.
Yeah. So you touched upon value in your conversation here. I want to maybe flip it a little bit and ask Sudarsan from his point of view as a representative of DOE that's sponsoring the institute. We've heard each of these panelists speak about what value this project brings through their discourse on the current state and the innovation that they're doing. And we can go back to some of those questions later on. But from your point of view, Sudarsan, how do you see the institute and the projects providing value to US manufacturing in general? Because that was the reason why these institutes were set up. So perhaps your perspective on that. And you're muted, I think.
Sure, thank you. Um, if you look, I think you you alluded to that. The common theme that is coming across from all the four panelists is what is the process? What do I want to do with then? What kind of optimization or efficiency I want to do from the decision centric, and then you collect the data, and then from the data you want to learn more about the system. So the context is similar, whether you are energy focused or reducing the zero defects and things like that. From the physics based models and then combining with machine learning models, what is that you are trying to learn and then predict better with your system. So one of the things from the DOE perspective is this is exactly what we wanted. All these big companies would never sit down and discuss this kind of thing. What are the common issues for them? How can reuse some of the technologies and ideas and concepts that they are doing it for food processing and used in, say, steel manufacturing or vice versa. So this is the real value for an institute, to bring in the common set of problems and trying to solve and create a storyline. What is the starting point of a smart manufacturing? What is the decision you want to make? And then how do you go about implementing that? So if you listen to the four talks, the common theme is appearing there. So that is exactly what this institute, with the knowledge network and bringing all these industry experts and academia together to discuss this problem in detail, and also look at what are the research issues at one end, but also what are the state of the art. You started off with the state of the art and where do you start and things. So combining these two, because you don't want to wait for an R&D to become a technology for 5-6 years. You want to move the needle faster and then try to implement and see how it can be done in different sectors. This is exactly what this institute was hoping to do, and I think it is doing.
Yeah, yeah, no, that's a good good perspective. I think one of the things that I've been with the institute for a little over 2 years, and it's been really great to see the cross-pollination that's going on already. I mean, these projects were the first ones that we launched. There's a great dialogue going on through project reviews and other conversations, and we hope to sort of accelerate along those curves as we have more of these types of sessions. But you correctly pointed out there are some common themes around data movement, contextualization. There's a lot around modeling and analytics. The multiple projects talking about the same kind of thing. So it's an important thing. So to that point, we always sort of say that there's always multiple options. If you identify a problem, you can either go do it on your own, partner with an organization outside of a consortium, and selected partners, and then go solve that problem. Or you come to a consortium or an institute like ours and say, this is how I want to do it. So from the standpoint of a manufacturer who's involved in these project teams, what is the critical role that CESMII plays? And like we as an institute bring something to you in terms of value, and then you as manufacturers bring something back to us through the projects as value to CESMII. So could you maybe talk a little bit about that? Let me begin with Charlie, perhaps. I think you're muted, Charlie. There you go.
Okay. In terms of value, whoops, I've got to kill this. Sorry about that. Cell phone in place. In terms of value to our industry itself, of course, we're looking at reducing costs and actually making things right the first time. So that's really the focus in terms of the Gaster-related work. But both of those impact energy consumption. And so from the standpoint of our internal company, that's really the principal focus. The other advantage we, of course, are seeing is we're being exposed and exposing our employees working on the activities to these new technologies, which is beneficial. Okay. From the standpoint of our, I guess, the impact on our industry in general, I guess we expect our project also includes a sensor development technology for the caster being done by one of our industry partners, and it's fiber optic technology, looking at obtaining data across the entire, continuously across the entire casting operation itself to monitor, for example, solidification boundaries and so on as the caster goes through, both from a quality standpoint, but also from a productivity standpoint, because a breakout would create a significant problem. So those sensors I'm anticipating, as well as possibly some of the techniques that are being developed in terms of the analytics tools, will ultimately become available for the industry itself. And then lastly, of course, for CESMII, the hope is, of course, that what we're doing will add to the capabilities and applications of the platform that's currently evolving.
Great. How about you, Larry, from Linde's point of view?
Yeah, I guess I would say a couple of things, right? One is, and they're kind of obvious, but let me give you some context. So one is the ecosystem itself is important to us. You know, as you mentioned, I think, you know, if we look at what we're trying to do, could we develop it ourselves? Probably, but not as fast or not with the same quality. Certainly, maybe not for the same cost, right? So really the mechanism that CESMII has to, you know, in our project, it talks about us and Texas A&M, but there's really about half a dozen partners as part of the project, each working on a different piece. So it really enables us to kind of bring together this ecosystem of smart people, right, and try to solve that problem. So that's one thing that's really important to us. And, you know, I think the second thing would be the platform. And from our perspective, it's interesting because our business is really essentially a utility, and we provide products to just about any other downstream manufacturer that you can think of. And in today's world, we think about more around, and those, excuse me, those manufacturers can be big and small. And we think about how can we share information, how can we share data, how can we share insight, how can we collaborate, how can we develop services to bring to our customers as well, right? Obviously, we have a lot of internal infrastructure to manage the flow of information, but what's the mechanisms that we can use to go outside of our own four walls and try to share those things? So I think that's another kind of forward-thinking opportunity that we're looking at, and one of the other reasons we partner with CESMII.
Very good. So from the standpoint of food and beverage industry, Chris, as you look at, you know, that's one of those industries where I think there are a lot more options in terms of going to consortiums and you know, groups of like-minded companies and industries that have been actually working together for a while. What was the thing that went through your thinking in terms of connecting with CESMII and not anything else? What was the value proposition for you there?
So it certainly didn't help that we're, you know, part founding members of CESMII with my former boss Jim Wetzel as a interim CEO, but I think we would have done it anyway. The reason is there's an innovative activity we'd want to pursue that probably wouldn't happen otherwise. What CESMII does is allows these kind of innovative activities to be kickstarted in a way that they probably wouldn't happen if it was just us by ourselves. So being able to network and partner with other companies like ThinkIQ and others in an environment that has helps with some of the funding, brings these things to life, like our project in particular, that I don't believe would have happened otherwise. I don't know that we would have pursued it. It's not that energy is not important. It's not necessarily the top priority among everything that we're working on. We've certainly got very aggressive goals around our contributions to society, our sustainability, those sorts of things. We get after them in a lot of different ways throughout our entire supply chain, not just our four walls. And so we're really talking inside of that plant. There's probably a lot more value in terms of our material flowing where energy is a small compared to losses around our throughput, losses around actual, materials being thrown out or wasted, or I shouldn't say wasted, but actually moved on to other alternative uses that we can't use them. But the CESMII side really allowed this to move forward.
Great. So Greg, I'm going to put you on the spot here. I know that you personally and Honeywell in general has been part of many institutes, I think, and you've been part of many such programs, federally funded programs. So what attracts Honeywell to CESMII in particular for this kind of a problem? And if you don't mind me asking, you're also part of America Makes. So there's this, Additive Manufacturing Institute versus CESMII. How do you see the differences between the two, in terms of bringing value?
Well, there's no doubt CESMII is on the cutting edge, Haresh. I mean, it's certainly the application of smart manufacturing within a factory setting. At a big company like Honeywell, although we're maybe a little bit of an exception, but I will say in general, there really isn't always an owner for that, right? You have owners for product, owners for thing that you collect revenue on, but you really don't collect revenue in smart manufacturing if you're Honeywell for the most part, right? So you need an institute like this to kind of garner the resources and to give initiative and give a reason for people to get together and say, gosh, this advanced manufacturing is really important, and this digital factory 4.0 is very important. And because otherwise you have a vice president who's a great vice president in charge of engines for business jets, and he says, why do I need advanced manufacturing, right? Mm-hmm. So that's where CESMII is very important. These institutes are very important. They help lay the foundation and the groundwork. And for me, CESMII has been fantastic because as a tech fellow for this area for Honeywell, it gives me the funding to kickstart some of these initiatives that we know are important. And I will say from a Honeywell perspective, I've been fortunate that they're very supply chain agnostic. So if it helps the supply chain, we're all in on it. And we just want a supply chain that can produce parts for us, right? And that's where CESMII is very important. And so, there's a lot of foundational work to be done that the national institutes can do. And we had great experience with America Makes and other institutes, and we've had great experience with CESMII. But I think it's a particular area. CESMII's kind of focus area is one that might otherwise get overlooked, but is very instrumental, smart manufacturing for almost every product, right? Yet the organization may not be in place within the company to drive those initiatives. If that makes sense.
Yeah, it does. It does. Yeah. So, Sudarsan, from a standpoint of someone who has a slightly broader context around how institutes are helping solve the larger manufacturing challenges, what you've heard today from our other four panelists in terms of how they've looked at CESMII as a value proposition, do you think that from DOE standpoint, CESMII is helping solve the broader issues across the manufacturing industry? What portions of that is CESMII addressing that's relevant from your point of view? If you can maybe share some of your thoughts.
Yeah, from listening to all the people who not only explained their project, but also said what are the challenges and why they come to CESMII and how they are interacting with things. It's very encouraging that the people who have lived, if you just collect all the people's experience of 30 years, so if you collect them with 150 years of experience we're talking about. So this kind of platform CESMII provides this is what exactly we wanted, to make sure that they are not solving their particular problem and looking for a point solution and then move on and then restart the problem again and again and again and investing in that. So the question of reusing and how can I reproduce the results. For example, if you look at, I think Charlie mentioned this a couple of times, so physics-based machine learning. So starting from data is one thing. and then looking for some insights out of the data. So there is data-driven approach. So traditionally, it is used in data exhaust, big data. But whereas human-engineered manufacturing system, I think Charlie mentioned this, you start with the decision. So I think you also mentioned that. So when you go from decision, and then you are collecting smart data, so what exactly you want to collect, how much you want to collect, and how often you collect. So if you go from that, I just have a question to the panelists to throw more light on this than myself, is having each of you listen to each other, how do you think some of the approaches and ideas and concepts that each of the projects are employing and approaching, how can you use that in your own project? And so for example, the data contextualization coming from Chris approach, how is that Greg can use it? Or the physics-based machine learning, how Larry can use it, there's vice versa. So that level of understanding will provide, we are not just looking only, like our problem of tunnel vision, but we are looking at what are the cross-pollination, horizontal R&D ideas and techniques that can come through. So that will actually accelerate and scale up this innovation across different sectors. So that's the tremendous opportunity here.
Yeah, I think it's a great point. I mean, we've been trying to find more avenues for all of our teams to have that kind of a conversation amongst themselves, and we'll certainly look for those opportunities soon here. I guess I'm going to look for, see if there's questions that perhaps some of our members from the audience have. So let me see what that looks like. I think we have one question here. Okay, this question is for all the panelists, and feel free to jump in, whoever wants to go. For your respective projects, what input of consideration was derived from the voice of the customer or key suppliers? Anyone in particular want to go first?
Well, I can jump in, Haresh. Certainly, we included a member of the supply chain CAM in the Honeywell-led project because, once again, the whole community for laser powder bed fusion additive is really a new community, right? And so we definitely wanted to do things that would be valuable for our supply chain. Honeywell does make some parts, but our long-term plan is to outsource those to supply chain. So we certainly have them as a member of the team, and they're actively help us make decisions as to which data would be valuable to collect that impact decisions.
Anyone else wants to chime in?
I guess from our perspective in terms of our supply chain is really our upstream folks are looking at the downstream folks as customers. So that's extremely important, and we need that additional input to basically take maximum advantage of achieving the yield savings that we anticipate across the total manufacturing line. I guess the other piece is, although we haven't addressed our end point customers directly or involved them, we recognize that anything we do to do things right the first time is very positive from the standpoint that we're able to deliver what we promise on time, rather than having to go through rework and so on to deal with yield losses or whatever that occur somewhere along the manufacturing stream.
Yeah, I guess from our perspective, our customers, we sell from our process plants, we're selling a commodity, oxygen, nitrogen, hydrogen. They don't care how it gets there, as long as it gets there. And at the end of the day, we really want to sell reliability to our customers. Really, that's what's most important to us. So if you will, in that case, then our key customers are really internal. And it's, again, how do we really have a competitive offering to bring down to customers? again, as reliably as possible. So that's really the benefit for us. And of course, as part of that, we need to do it fast and we need to do it cheap. So that's where our targets are.
Right.
In our case, voice of the customer, we've got a few layers. One is the person who would configure an energy type of solution, could be an integrator, controls engineer, making their job much easier. We've tapped into those folks. They're sitting with us in each project meeting. The analyst, or the one who's actually consuming the data and output in order to drive the improvements, would be our system engineering role. Each line in our company has a system engineer, as well as the energy engineers. We don't have as many of those, but we went directly to our energy team as this idea was brought forward and awarded to make sure that what we were putting together was in fact going to deliver on their needs.
Yeah, I think one of the interesting things about this whole field about smart manufacturing is that, in the end, you're actually addressing, from a customer standpoint, you're addressing, things like quality and cost and, delivering in time. And then you backtrack from there to say that, what is there in your current systems that allows you to do that better, right? Whether it's quality. So in Arcelor's case, you're talking about quality. In your case, Chris, it may be just as simple as saying that, what is my energy footprint of this box of cereal that I'm picking up at Walmart, right? And you backtrack from that and say, well, do I have systems to help me get there, right? So I think those are some of the ways in which we can connect back into the customer. So that's a good question. I'd welcome other questions through our Q&A tab. Now's the time to do it. While we are, there's one more. How would you recommend a small to medium-sized manufacturer get going with smart manufacturing and best engage with CESMII? So maybe I can take that. So if you look at some of our project calls that have gone out, one in particular, the RFP2 Wave 4, as we're calling it, is around something called innovation projects. And these are smaller projects. We're expecting these projects to last between 3 to 6 months. Smaller size, you don't have to have a whole lot of commitment to that. It's federally funded 50%. The smaller manufacturers can, join hands with the systems integrator perhaps, and come up with an idea around an innovation project that helps look at a particular use case, but at the same time helps us with developing some information models and applications that can go back into our platform. So that we feel is a good way for smaller manufacturers to engage with us. But the other side of the story might be that you have 4 representatives today here that come from fairly large companies, but they have their own supply chains that is made up of small and medium manufacturers, right? That's the other way to get engaged, through your supply chain partners, if you're in that situation. But again, feel free to contact us individually if you have some specific things that you want to know, and we can help in terms of.
Just a comment on that, Haresh.
Yeah.
2 quick things I would regardless of the size of your company. First of all, at least what we advocate is not having a smart manufacturing strategy per se, but having a business strategy, and then trying to answer how smart manufacturing can support that, especially in a company like ours, which is making stuff, right? We're not selling digital stuff. We're selling molecules, basically. So that, I think, is the first thing. And then think about what your foundation is and build upon that. I think I see too many times where people want to pilot something, I'll call it fancy, right? This AI solution that does X, Y, Z, when they just lack basic visibility, for example, of the data in their factory, right? So really think hard about what your foundation is first, and then you can build on top of that.
Yeah, I think the other thing that I bring to light sometimes is the fact that, smart manufacturing doesn't have to involve the whole picture that you saw before, right? You can take pieces of it and say, for me to have a small drill press that I have, and to be able to tell when the drill bit is going to, break, right? If I have a tool that allows me to do that, that's smart, right? So you can start with smaller pieces like that, and then kind of build your strategy around it. So, yeah. Good. Okay, I think there's more coming in here. Let's see. Does management promote data-driven decision-making, incentivizing middle managers, directors, etc., to think data first, creating a culture to use data at every turn? So I guess this goes back to our industry members here. What types of communications and culture change and engagement is necessary to drive through your organizations for making this data-driven decision-making a more of a culture within your companies?
So in our case, in general, data-driven decision-making, absolutely. It's front and center in our corporate strategy. That's talked about internally. Different functions within the company have centered around this. We have a very strong information technology staff in support of this. And so I would say there's heavy focus on data-driven decision-making at our company.
And I would say for Honeywell, our president is a software engineer. They came from our digital enterprises, and we're told that we're now a software industrial, and so we're going to use data, leverage data, help other folks use and leverage data as well. So we're very much driven at Honeywell, but it starts at the president, who is a digital software engineer.
Great. Well, when we started this conversation, I knew the time would fly, and it has. We're almost at the close of the hour here. There's been a great conversation and highlighting of some common challenges and common themes that we've heard around things like leveraging the data and the information and structuring it correctly, becoming more predictive and proactive so you can address your challenges around things like quality and energy and productivity. We heard some common themes around how leveraging CESMII as a partner was a good thing for you for this project and in general for your company, for your industry. So all very, very valuable feedback that we've got from you and perspectives from you. So thank you for doing that. I want to thank all the panelists for being here today. And as I said, this was a recorded session, so this will be made available to everybody. With that, we will close this session. Again, thank you for joining us today, and have a safe rest of the week.
Thanks, Haresh.
Thank you.
Thank you.